Um, we have integration today for the eighth lesson for integration. This is about exponential functions. How do we integrate exponential functions? The first one says the integral of e to the 2x dx. Do not forget this one we have immediately attached with what d is the variable of integration. So it tells you that we are integrating with respect to x, even if it appears like you see another letter or another variable. But x is our concern, meaning this is what a function in x. So let's assume that the function contains other variable or other variables. But what we have here is what we regard as the function we are integrating. Okay. So the e you see here is not just an ordinary e. It represents exponential function. Yeah, exponential function. All right. So in that case, how do we integrate exponential function? To integrate exponential function, you only need to differentiate the power. Yeah, first of all, what is the power of e? The power of e is 2x. If you differentiate this, what do we get? We get 2. Yeah, so once we get to, what do? We say, we write first what we are given, e to the 2x, then we divide by the derivative of the power. The power is 2x. We differentiated it to get 2, so we divide by that 2. Then we say plus c. Yeah, but this can also be written as here is 1 over to have e to the 2x plus c. This is correct. This is correct. Okay. Now let's see the second one. The second one says the integral of e to the 6x minus 5 dx. This is also an exponential function. We want to integrate it. Y plus c, because there are no limits. So this is like indefinite integral. It is what? An indefinite. The definite comes with limits, and once there are limits, we don't say plus c. Okay. So the same thing applies. Don't say because the power is an expression, so it's going to be difficult. Just follow the principle that says to integrate an exponential function, you identify the power of e, which is what? 6x minus 5. So with this power of e, what do? We differentiate it. To differentiate 6x, we have 6. How about minus 5? Minus 5 is a constant. So differentiate a constant is 0. So the whole of this one will give us just 6 if we differentiate it. So what we do now is we write what we are given, which is e to the 6x minus 5. This is what we are given. Then we divide by the derivative of the power, which is 5. So because of what there are no limits that makes it indefinite, we have to say plus c. It is optional to say 1 over 5 e to the 6x minus 5 plus c. Do not forget c, and do not underrate that even if you don't write c. No, you need c. The third one again says the integral of e to the half x dx. Yeah. So one thing about mathematics, you don't need all the examples in the world for you to understand. Yes, your concern is supposed to be the rules that involve the formula, the principles, the axioms, so many principles, the theorems, yeah, the principle, the rules, so many factors that you need to consider in understanding a particular topic. Don't say like you need 50 examples, you need 70 examples. Some videos I do like 4, 5, simply because I don't want to do like 4, 5 separate videos. So here is a single term. Here is an expression. Here is a single term, but with a fraction. Here is a fraction. Here is expansion. So with these 5 in one video, you should be able to understand the basic concept of integrating exponential functions. All right, the same thing applies here. We want to integrate this one. So what do we do? What is the power of e? The power of e is half x. Don't say because it is a fraction, so you find it difficult. Once you can differentiate 2x, you can differentiate this. You differentiate 2x to get 2. If you differentiate half x, is half. So we write what we are given, e to the half x, then we divide by the derivative of the power, which is half. Then we say plus c. I hope it is clear. So this is now equal to. Now I want you to understand something here. Here is the main division line. This one is the main division line. Below the division line, there is a fraction. Here is the main division line. You can see it. And below it, there is a fraction. And this fraction has a denominator. This denominator moves to the top. Yes. This is not about calculus. This is not about integration. This is about fractions. Below the division line, there is a fraction. This fraction has a denominator. The denominator moves to the top. So once this one goes to the top, we have 2e to the half x. What remains as a denominator is now 1, which we always ignore. So we say plus c. So this is the integral for this one. This one is this. This one is this one here. So if you want to copy, then pause the video, then copy. I want to erase so that we can discuss the remaining two. All right, so we have the fourth one here. The fourth one says the integral of 5e to the 3x minus e to the what? 2x over 2e to the power x dx. All right, we want to integrate this. First of all, integration is not only limited to direct application. Yeah, in some cases, you need to simplify what is given. And some cases, you cannot simplify to your desired state or form. So the functions that normally or sometimes we cannot simplify further, we have other techniques we apply. And one of the prominent one is integration by substitution. When we cannot simplify, for it to become the form or the state which we can find it easier, or which we can integrate it or differentiate it in a very simpler form. Okay, so let's see if we can simplify it or we cannot simplify it. But the fact that the denominator is a single term, that makes it easier. Let's apply this principle that says 2 over 3 plus 1 over 3. The denominators are the same. What we usually do, we take 1. Whether it is plus or minus, now we can take this 2 plus 1. Yes, having considered one of the denominators as this here. So, if this is true, it tells you that if this takes us to this, then this can also take us to this. How? We say 2 over 3 plus 1 over 3. What if it's a minus? The same, 2 over 3 minus 1 over 3. So if this is true, then we can say 5e to the 3x over this one, 2e to the x, minus, you see, I just demonstrated that, minus e to the 2x over 2e to the x. Don't forget we have the x, and the x affects everything, is for all. So the integral, you need to understand when differentiation or integration takes place in calculus, or when it has not taken place, we are just simplifying. Remember, basically, to integrate an exponential function, we differentiate the power. From there, we write what we are given, we divide by the derivative. And you've not seen me doing that. So it means the reason you keep seeing the integral symbol. Keep seeing the integral symbol. So what we do is, here we have 5, here is 2. So we say 5 over 2. There is E, there is E. Remember, indices tells us that this one here, they are the same, we take 1. Division, we subtract this minus this. E, they are the same, we take 1. Division, we subtract. But we write the one at the top first, which is 3x minus this one here, x. I hope it is clear. We have a minus sign. So here is 1, here is 2, which gives it half. E, we take 1. This is 2x minus the x down. Why we don't add? Because this is division and not multiplication. All right. So the integral of yes, we are still simplifying. 5 over 2 e to the 3x minus x is 2x. Half 2x minus 1x is 1x dx. Now it is in the form we want. So what do we do? Pay attention. You say 5 over 2 e to the 2x. Remember, we usually write first what we are given. Now we've written down what we are given. I'm dealing with this. This one is waiting for us later. When we are done with this, we can go to that. I've written down what we are doing, what we are given. What is next? We divide by the derivative. The derivative of what? Of the power 2x. If you differentiate 2x, what do we get? We get 2. Here you don't integrate, you differentiate. You differentiate the power. Differentiating the power is part of the process of what? Integrating exponential function. If you differentiate this, what do we get? We get 2. And that is what we used to divide. The same thing I did for the previous 3 problems. Minus. We have half e to the x. We divide by what? We divide by the derivative of the power. The power is x. If we differentiate 1x, we get 1. So we differentiate by 1. So that is the reason. And in integration of exponential functions, e to the x is always e to the x. Because the derivative is 1. And division by 1 will not change anything. Okay. When doing mathematics, you need to be accurate. Yeah, you need to be highly focused. So meaning you must not forget C. Don't be carried away. Okay. So I explained something about fraction. The same thing I want to do here. Look at the division line. Main division line. This is not the time where I said below there is a fraction. Now at the top, above this division line, there is a fraction. This fraction has a denominator. The denominator moves to the bottom. So it means always the denominator is moving. Main division line, 3 over 4, 2. Main division line, 5 over 4 over 7. Here is the main division line. The numerator is a fraction. The denominator moves to the bottom. So it becomes 3 over 2 we have originally multiplied by the 4 that is moving down. Look at the main division line. Below is a fraction. The denominator moves to the top. So the 5 we have originally multiplying the 7 coming, remaining 4. This is fractions. I hope it is clear. All right. Don't forget. So if that be the case, a division line is here, then at the numerator there is a fraction. The denominator moves to the bottom. So this 2 is going to join the original 2 we had where this position here. So at the top remains only 5. So 5e to the 2x over. This 2 goes down. And once it goes down, it's not going to appear like 22. It's not going to appear like 2 plus 2. It is what? 2 times 2. The one coming multiplies the one we have there originally. So 2 times 2 minus half e to the x plus c. You know we neglect this, we ignore it. So 5 over 4 e to the 2x minus half e to the x plus c. This is what we have. I hope it is clear. Now let's go to the last one. Yes, the last one. That is 5, the integral of e to the x, 5 minus e to the 2x dx. One of the reasons we simplify because there are two functions, the numerator and the denominator. So here again, we have a product of two functions, though each of them is a function of what? A function in x, function of x. We have e to x, we have the brackets, but we need one function so that we can integrate using the simplest way. So what we do is we expand. This times this is 5 e to the x minus this times this is e to the what? 3x. Why 3x? This times this, the base are the same, we take 1. The bases are the same, we take 1. Because of multiplication, I said this times this. So we add the powers. X plus 2x is 3x. Then there is dx. Now we can go as usual. To integrate exponential, write what you are given, you divide by the derivative of the power. If you differentiate x, we have 1 minus. Write what you are given, you divide by the derivative of the power. You differentiate 3x, we get 3 plus c. So 5 over 1 is 5 e to the x, 1 here over 3 e to the 3x plus c. So this is the integral we have. Thank you for watching. Don't forget to follow, like, share, and comment. See my next video.